Okay, so before we had windowed operating systems like Windows, OS X, Mac OS, Linux, etc., computers had a text-based interface to them, some kind of, well, today we call a console, shell, or terminal. And that's one, because the operating systems weren't created yet, but also the machines themselves were very expensive and very big. I mean, it wasn't uncommon at one time for a large company or university to only have a handful or less of these machines. And so they would be housed in a certain part of the company or university, and users of that machine would connect to it via some kind of terminal. And that's literally just some kind of connection to it. And on the other side of that terminal, not the computer itself, but in the office of the individual using it, you'd have some kind of teletype, keyboard, monitor type setup. But it wasn't the computer itself. It was just a way to do I/O and interface with it. And you would interface in a text-based environment. So we still have that environment even locally on our personal computers, and then our windowed operating systems sit above that. So on a Windows system, you have DOS, MS-DOS underneath. On a Linux system, you have some variant of Unix underneath. On OS X or Mac OS, you have BSD Unix. So on the Windows side, you would open up a DOS shell or prompt or terminal, or PowerShell is what they've kind of moved over to now, Windows PowerShell. And this gives you the look and feel of what a pre-windowed operating system would look like. You would issue commands to the computer to, navigate files, create files, edit files, submit jobs, things like that. So there are commands that you can learn here depending on which subsystem that you're using, whether it's DOS or it's Unix. I'm not going to go through all of them now. That's not what this tutorial is about. But for example, if I wanted to look at all the files in this directory, I would type dir command and I could see files in there. I could change directories with the cd command. So if I wanted to go to the desktop, cd, and then if you have it configured a certain way, usually you can press tab or something to auto-complete your different directories here. So I'm going to go to desktop, and you can see my path has changed. Now I'm in the desktop folder, right? And then if I hit dir from here, I'm seeing things that are on my desktop. But of course, there's many other things that you can do. There's lots of commands. If I type clear, this clears the screen. If you're on a Mac or Linux box, you probably have a terminal shell that is using perhaps bash or some other variant of shell, and this on this side you're going to have different commands, right? So these are going to be Unix commands. So dir is not the command that you would use, although it might be recognized or supported. Usually it's ls, and it has lots of options associated with it to list the information differently, or different things that you're looking for, if you want to see permissions or dates or everything. And we could still use our change directory to go in and out of directories. So if I wanted to go into this directory here, now I'm in a different directory, but then I could go back. So dot is for the current directory, and dot dot is for the previous directory. So remember, when people were in this text environment, they were typing lots of commands. So there's lots of succinct language here. Also, memory wasn't as high back then, so things were pretty shortened in terms of even commands, file names, all that kind of stuff. So in this directory, if I wanted to go back up to the previous directory, I would do cd for change directory, dot dot, and this brings me back to where I was before, right? And I could do my ls command here and see the directory of information I saw originally here. Okay, exit to get out of these. All right, so this video is really intended for CS1 and perhaps CS2 students getting set up. At least for my students, they're working in Java, so you've downloaded some JDK, hopefully a modern JDK, and you have that installed and integrated properly so that when you open up this shell or terminal command prompt environment, you should be able to type java-version and see a modern version of Java that you have installed. Right? If you don't see that, then you need to look at a previous video or a document on how to install the Java JDK specifically, not just the JRE, because we want to have Java C, the compiler. You want to make sure that's installed because we're going to be using that as well. Okay, so that's me checking it in the Windows environment here. But again, if you're on Mac OS, or you're on a Linux box, you're running that from your command shell, perhaps Bash, and you should have it configured through there as well. Because I want to show you that you can do our compiling and our building here through the shell, but then I'm also going to show you some stuff about the IDE as well. So there's another aspect to all of this, which is Git Repository, and wherever your teachers have that hosted. In our case, we have this on GitHub, in GitHub Classroom specifically, so our assignments are up on there. So remember, you've already created a GitHub account, so you're going to log into that. You're also going to log into classroom.github.com as well, and that is going to communicate with github.com. It's two separate sites, right? Classroom is a subdomain of github.com. So it's going to ask for permissions to be able to communicate back and forth, and you want to grant those permissions to make it as easy as possible. If you see this window here, you don't really want to do anything with this. What you want to do is click on the individual assignment that your professor has given you. There should be a URL to a classroom.github.com Git repo, and you're going to click on that. Once you are logged in to GitHub Classroom, you're going to click on that. It's going to ask you, do you want to accept this assignment? So this is where it's asking you to bind your GitHub ID, whatever that is, to whatever the roster ID that the teacher set up for you in the class. All right, I don't have one set up for this GitHub account that I set up here, so I'm going to skip this, but this is something that you would do as a student. And on this screen, it's saying, hey, do you want to accept this assignment? It has this prefix here to the repository, and then it has your GitHub ID after it. I'm going to go ahead and accept this. It's going to create a repository for me. Let this finish working. You don't want to mess it up. Been using this setup with hundreds of students, and occasionally something will happen to interrupt the process. Not always the student's fault. Sometimes it's server side, but you definitely want to give it a couple of minutes to finish. You want to make sure you accept any permissions with your GitHub account. All right, and then you want to go ahead and refresh this page, and you should see eventually that it has set up your repository for you. So on this page, it depends on how your professor has it set up. You probably don't have access to join the organization itself that they had set up for the classes, but they might. So you could click this and see if you're being accepted into it. If not, what you really just need is your repository, your link to your repository for your specific assignment here. So this has the prefix that we talked about. It has my GitHub ID here, and if I click on this, it's going to take me to a github.com repository that's been created under whatever my classroom organization is. And this is my starting code here. And you can see, if you look at these files, you can see there's a source folder here. There's a Java file here in this case, because this is a Java assignment. And we've got some other stuff here. The Git Ignore, you could essentially ignore for now if you're an early student. But basically, this has information in it for Git to ignore certain types of files. So when we're doing lots of compiling, and perhaps the operating system is adding cache files and other things to our directory, maybe even hidden things that we don't know about, these are usually things we don't want to check into our repository. So this is a file that's telling Git, whenever the person is working with this repository, that the repository system, Git, can ignore these types of files. So for now, like I said, you don't really need to touch that, but that's what that file is. This is just a markdown file that has this information here, right? If you click on this, it's literally the same information. It's just a README that your professor has set up potentially. And then we have some other files here, only because I checked in the project for IntelliJ and IntelliJ ideas, working files. These may not be in your repository for whatever your professor has set up. I did this to make it easy for my CS1 students, and then my CS2 students, I don't check that in, and they can use whatever kind of setup that they want. Now that we have our repository here, we can clone this repository locally, so we have a local working copy of this information, okay? And there's many ways we can do that. You do need a client. You could be using that client through the command shell or the prompt like we talked about. If I opened up PowerShell here, I could be using Git if I have it installed. I could be using it from the command line. It looks like my current configuration, I don't have it installed right now, so I'm not going to use it through there. You can also, and I advise this for my students, that you can download Github Desktop. It's a completely separate product, a very streamlined, simple visual client to just get you used to working with Git even before the command line. So I'm going to pop up GitHub Desktop here, and I'm going to clone that repository. If you've used it before, it might have an old repo opened up at the moment, but I'm going to go add clone repository, and there's different ways that you can clone it. You could have it search right on GitHub for you. You would have to be logged in for it to do this. Like it's searching repositories that you have been added to. To log in, if you go to File Options here, you can see that you could log in here, right? So if I sign out, you could re-log in here. I think now these days it routes you to the website. So as long as you're logged in on github.com through your browser, it will log you in through GitHub Desktop as well. So I'm logged in as this user. I'm going to go ahead and clone a repo. You can do it through here. I could literally just select this repo here, but I'm not going to do it through there. I'm going to open up my link to my repository again. You might want to, I'm going to go back a page. You might want to copy this while you have it. Just for now, until you get used to this whole setup, you might want to copy this repository link. You should be able to find it again later through your account somewhere. Sometimes it's hard to find because, again, github.com and classroom.github.com are kind of separate. But if you copy this, then you won't lose it. So I'm going to go back to it here. And this code button, it's saying, hey, this is information about this code base. So I'm going to open this up. There's many options here. I'm going to copy this repo link here. The repo link is literally the same URL here with a .git extension. So I'm going to copy that. And then I'm going to go over to GitHub Desktop. There's a couple tabs here. So this, again, is looking it up for you. Here's URL. There's two things you always need in all of these. You need where are you getting this information? So this is the repository on github.com. And where is it going to go locally on my local drive here? So I'm going to do this through the URL tab. I'm going to paste in the URL to where that repo was with the .git extension. And I'm going to put it right on my desktop here. So I'm going to say, put it on my desktop. Okay. You can see it's got the same name of the repository. That's what it creates as the default folder. You could change that. I'm going to keep it the same for now. So I'm going to hit clone. It's going through that, downloading all the information. If it's a large code base, this process will take longer. It says there's no local changes right now. So everything in this folder here is synced up. These are the same files that are on the code repository here. So your professor can access this, and whatever's up here is what he or she can see, right? If you make a change to a file in here and don't push it back up to the server, they're not going to be able to see that. Okay, so for example, I could, open up this Java file in a text editor, and I could start making some changes to this file here, right? I could do something like this. Okay, and I'll just put a comment there. You can see that there is a change now, right? That's the comment that I put in there, and this GitHub Desktop is communicating, this client is communicating with this local folder versus what's on the server, and it's telling you that there's a change there now. Okay, so we want to go ahead and start changing this information for real. Obviously, you're going to edit it with your IDE or at the very least some kind of primitive text editor. But I haven't made any changes to the code that is anything serious. In fact, because it's not, we could just say, you know what, forget about this, discard any changes, right? So now it goes back to the way it was when it was checked in on the server, right? We have exact copy now. I'm going to go ahead and at first open this up with a shell. So I'm going to use PowerShell. You could use a DOS prompt. Again, you could use Bash, Terminal, whatever program you're using in your command line interface. And I'm going to go to this directory. So this directory is on my desktop. I'm going to type cd desk, right? You could also do this, like, what are the things inside this users directory? Oh, what's inside here? Okay, there is a desktop folder inside here. So I'm going to say cd desktop. That's where it started me. I mean, if you didn't start in your user directory, you would have to find where this is. It's the same file system that you have in Windows Explorer. So however you find the desktop or wherever your folder is in Windows Explorer, it's the same path. In fact, I could do things like this. Users, my username, my desktop here. this path here is where I really want to go, right? So if I wasn't there, if I was somewhere else, I could say cd double quote, paste in my path here that I copied from Explorer, and then submit this. Also paste with right click, and it will change to that directory, right? So there's different ways that you can do this, all right? But from the desktop, it is on this directory. I'll do a dir again, and you can see that that's the directory there. So I'm going to say change directory to csci, and it gives me this path here, okay? What is inside here? That's the same stuff that we looked at on our GitHub repo here, and I can start working with this stuff. In this case, there's nothing I want to change. I just want to compile and run this in Java. There's some source files in here. I'm going to go into that source directory here. Okay, I'm going to say cd source, and then from here I could compile this. Well, what's in here? It's a Java file, so I could compile this with Java C. I'm going to compile. You can compile this single file, or if I had multiple Java files, I could say star.java. This is going through the compilation process. It's very quick because it's a small file. In fact, now it has created a class file in there. The result, the bytecode result of compiling this Java file, this is the bytecode here in the class file, and that's what we actually run. Okay, so we're going to run that. That's going to be the name of the class that is inside this code. So if I were to look at this code again here, right, this Java code, the name of the class is also main, right? So I'm going to run that file. I'm going to run this main.class, moving this stuff around for you, with Java. So Java space main is how I would run this program. Press enter, and you can see it just prints out hello world, as we saw in the code. That's all it's doing here, something very simple. Okay? So I could make a change here. For example, hello, my name is Joe. All right, save this file, recompile here, run it again. Okay, and we have our change there. So this is one way you can work with changing your code. Obviously, editing in Notepad++ isn't fantastic, and only running inside of a shell isn't fantastic either, because you're not going to have as strong debugging tools that you can use to figure out bugs once your program gets larger. So we want to use an IDE, all right? And I've had my students download IntelliJ IDEA. I'm going to go ahead and run that now. Okay, we have IntelliJ IDEA open. Now, if your professor has provided a project in the IDE that you're already using, then you can usually just open up that folder, right? Because there is a project here. So if you're using this IntelliJ IDEA, or you're using NetBeans, or you're using JCreator, or you're using VS Code, or whatever IDE that you're using, and again, for my students, I'm comfortable with them using whatever they want. I just provide IntelliJ IDEA just as a default, as a startup, to make it easy for them if they've never used anything. But whatever you're using, if your professor has already checked in projects, you could probably just open up that folder or that project and things will just work, unless you and your professor are on completely different versions. There might have to go through some conversion, but things should work. So in this case, I'm going to go ahead and open up an existing project. So I'm not going to create a new one. I'm going to open up an existing project. I'm going to go to my desktop, and if it looks on my desktop, you can see even in IntelliJ, has like a little, it's the icon for IntelliJ here. It has like this little black square here. It's saying, I found this folder, and it definitely has, an IntelliJ project inside of it. So I can work with this thing as is. All right. If your professor didn't provide that information, so for example, let me do this. I'll copy this directory. Okay. So I have a copy of it, and this is not going to be on GitHub or anything, so I'm going to delete all of this stuff. Delete this. Right? So let's say your professor only committed up some source, right? And a README in this case, okay? And you want to be able to work with this. In IntelliJ, if I go to open this, you could open this folder, but there is no project that's created for me already. I'll call this example, okay? So I have seen it where I have seen some student projects where if we go ahead and open that, notice it says it does not recognize this as IntelliJ IDEA project folder. If I go ahead and open that, ideally it would detect that this is not one and it creates a project for this folder. Okay, and so I can still work with it the same way that I would before. It looks like it's opened up the README by default. This is the project tab here that shows our files here, and we would open this up. I don't see a project file here, so let me go ahead and let's go ahead and close this. Let's see what happens. Let's see if it creates a project. Okay, it did create a project there, so it looks like everything might work there. So you saw that we didn't have a project there. With IntelliJ IDEA, we opened up that folder and it created one for us. So now when we run it again, we could, potentially double click that or open up that project. They have a recently opened projects window here, so you could click that or you could go find it again. But it looks like this is probably going to work. But I wanted to warn you that if it doesn't create that project file in that root of the folder above the source files, then it may not see these source files as class files, and it may give you some additional headaches. I just want you to be aware of that. If it creates the project file, let's say in here or some other place, things are not going well. In those cases, what you could do, so I'll show you another way to set this up. I'm going to close this. I'm going to delete all this as if it never happened. In those cases, what you could do is make a project. So I'll delete this. We'll let IntelliJ make a new project for us, and then we'll copy over the source and stuff to it, to this particular directory. So because this is the directory where we're using Git and our Git client is connected to, we still have to use this directory if we want to communicate this back to server. But if you need to create something here, and IntelliJ saying there's files already here, you could literally just take all this stuff out, right? And then you could make a project in this folder or somewhere else and then copy the stuff over. Okay, so I could say, open up IntelliJ. This doesn't exist anymore, so we're going to get rid of it. I'm going to say project, create a new project. What SDK do you want to use? Hopefully it finds one of the ones that you installed, your latest one or whatever. We want a Java project. We're going to go next. We don't need a template. Here is where I'm going to, find the path to this directory here. So I'm going to find it in Windows Explorer, but basically you want wherever that thing is located that you downloaded your repository from the server. I'm going to put that in here. Project name, probably want to keep it the same. I'm keeping it the same because I had already checked that in. But if your professor didn't check anything in, you could call this whatever you want. Okay, so I'm gonna do that. Now I have a project that I created from scratch. Now there's no source set yet here because I just moved all that stuff out. I was showing that if your professor didn't check in a project, you could create one at this folder and then just, and in my case, I have some other source here. I could move that source over, right? I could merge this source in with that source like so. I'll get rid of this class file as well. Right? I could move, there was other things here. The Git Ignore was here. This README was here. I don't need this old IDEA folder, right? This was an example of if the professor had checked in this stuff, and I was showing you that if they hadn't checked in this stuff, you could create the project and move that stuff over. So there's many different ways that you can do this. So again, if your professor has checked in the project of the files, you're good if you're using the same IDE. But if you're not, it's just source. You'll have to create that project in the folder and then make sure the source that they gave you is being utilized by that project. Okay? I am going to revert all of this. I'm going to get rid of this. I'm going to get rid of all of this. All right? I did that when I still had this open. That wasn't smart. So I'm going to get rid of all of this, delete this. Okay, so now I have an empty repo. GitHub's going to say, my GitHub Desktop, my client is going to say, whoa, what's going on? Your professor gave you a bunch of files here. Now they're all missing. They've all been deleted. So I'm going to just highlight all this and say, you know what, discard the fact that I deleted these files, and it's going to go re-get them from the server. All right, so now, again, there's no local changes. Whatever I have here locally is what's on the server again. Okay, so in this case, the professor, me, has checked in a project file, and I can just open IntelliJ with that information. Okay, so that's what I'm going to do here. Okay, because we know this repo already has an IntelliJ IDEA project inside of it, I can just go ahead and open it. I'm going to go to this directory, and it should recognize, yeah, you can see there's a little black icon here, and it basically, this is saying, this is the IntelliJ icon. It's saying this directory definitely has IntelliJ project inside of it. So you can go ahead and open that as is. And again, the first time you're doing this, there might be stuff running in the background. Just let that finish. You know, give it a couple minutes if necessary. It shouldn't take that long. This is our project workspace area. Here's our source files, because there's already a source directory that was there. And here is our code. Okay. Now, obviously, there isn't much going on here in this particular project, but we can compile it, run it. You do that with the build menu tab here. So this is where you compile your projects or modules that you have here, equivalent to calling Java C in the shell. And if you had any errors, you know, something like this, then it's going to compile and pop up some kind of error window that shows you the types of errors that you have. And it, you know, the IDEs these days are very good. They give you the line number, you know, in which file. All right, so I've built, and now I need to run it. Now, when you go to run it the first time, it's going to say you need a configuration, right? I need some kind of configuration if I want to do any running or debugging. And the configuration just, it's telling the IDE what kind of options you want set when you run this, what SDK do you want to use when you're running it, where's the entry point to the program, so what is the class, if you're working in Java, what is the class that has the main method in it. This is our main class that has our main method inside of it. So we need to indicate that information. I'm going to go to add configuration. When you do that, it'll pop up a box like this. These are the templates. So these are like the default these are the default settings that it's going to give you when you start these types of configurations. We're going to close that. We're going to hit this plus, add a new configuration of type application, because this is a Java application. You can call it whatever you want. That's not really important. You can have many different configurations here for this project if you're running it, let's say, with different arguments. The important things, and this may look different depending on the version of the IDE that you have, but the important things are you want to make sure the SDK is, or the JDK is set somewhere. I'm using the latest one that I have installed, and you want to make sure you set the main entry class. So my main entry class here is called main. This is the one with the main method here. I'm going to hit this little button here, browse, and it should find it if things are configured properly. And like I said, the project file is in the right place relative to the source and everything. It should find this. If it's not, that's an indication that something is configured incorrectly with IntelliJ here in particular. So I want this main class here. And for those of you that are running with command arguments or program arguments, so if you have a more complex program and you can pass in the starting arguments, this is where you would specify them, right? Anything delimited by spaces here, this would be a separate argument here that's passed into your program, and you can work with them. The working directory, you can leave this for now, but it's usually the root of your project folder here. And once you get into loading files, resources in general, all relative paths are going to be relative to this unless you change it programmatically at runtime. So this is kind of like the default data directory of where files can start to be loaded from. So I'm going to hit apply, OK. You can see the name of my configuration is there. I can go ahead and run it. It's rebuilding because I had made that minor change. So it's rebuilding and it's running, and you can see there is our output. Right? I'm going to take this, add a few more lines here, maybe add a variable. Let's actually give it a value and print that out. Oops. The value of x is x. Whoa, x. All right. Let's change this so it says something interesting. Okay. I'm going to go ahead. We don't have to create a new configuration. I can run this as is. There is our output, right? And if you wanted to even debug this, this is one of the reasons why you have an IDE, not only the nice editor and syntax highlighting and IntelliSense and all of that, but also the debugging, right? If I put a breakpoint here, and I can do that by clicking on this gutter here, or there should be, you should have hotkeys set for these. So in debugging options, oh, here you go, toggle breakpoint. So F9 is the hotkey to toggle a breakpoint here. And I'm going to go ahead and debug now. So that's it's a different button here. You want to hit debug instead of run. You can also hit it here. It's going to start executing the program, and it's going to pause or halt on this first line that it encounters that has a breakpoint. That's why it's called a breakpoint. It's going to break your program at this point, right? And here you can start inspecting information, right? You could see the, this is the console output. So this is currently what's been outputted, nothing. And if we click over to debugger here, we can start to inspect these variables. So we have a variable x. We have a variable args, which is a string array. It's empty. It's telling us all of that, right? And then we can step through this line by line. I'm going to go to run, debugging actions, and I'm going to go step over. That's the next line. It looks like F10 is my hotkey, right? So if we go to the console, you can see it's printed out this first line now, right? And then we're going to step again. We're going to step again, and you can see that's the information being printed out. I'm going to go ahead and finish up the program here. We're done. We're going to close this out. Now we've made our changes. If I were to open up my Git client, GitHub Desktop in this case, you can see that it has all of the changes logged here, right? It's telling us this workspace file change. Remember, only because the professor checked in a project and some settings files, so those may change when you're adding files or removing files or minor settings that are changing. If there was no project checked in, then these would not be, files that are in the repo. You could add them if you wanted to, but you don't have to. But the important change here is the source code file, right? We made these changes here. We want to make sure the professor can see these changes. So I need some kind of commit message to say these are the things I changed at this point. Added some stuff. Not a useful message. All right. Commit that. Now, it's changed my local repository, so I've updated my local repository, but the professor cannot see my changes yet. If I go back to the repository on GitHub and we look at the latest source code, it's still what was there before. After all, there's only been one commit so far, it's saying, right? This was the initial commit by the professor. So we committed that in locally. Now we need to push that. There might be a little update here. It depends on what version of this client that you're using or what your client even looks like, but there should be some way to push or publish this information back up to the server-side repository where you initially cloned this information from. All right, so we have no more local changes now, and if I go back to the repository on GitHub and refresh this, you can see there are now 2 commits, right? This is the newest commit that came in, and the professor could click on that and see, what changed from that particular commit. You can verify that yourself. We can inspect the latest version of the source file here, right? And this has all of our changes. So once you make your changes, make sure you commit them locally and then push them up to the server. Otherwise, your professor can't see it. And I run into this with students occasionally where they have definitely done the assignment and it's on their their local repository on their hard drive, but I don't have access to that, right? So I can only grade them on what's on the server. And if they don't push or publish this stuff, then they don't get a good grade because I don't have the changes. So hopefully that was helpful. You know that if your professor's using Git, GitHub, you can use some kind of client to clone that repository locally. If you're working in, no matter what language you're working in, Java, C++, Python, or whatever, you can usually interface with that through the shell or command prompt or terminal through this like text-based interface where you're calling the commands to compile and run your program, but you still need to edit it. You could edit it in the shell, but that's kind of an archaic setup at this point. This isn't the 1970s. So you want to use some kind of, at the very least, some nice text editing program, if not a full-fledged IDE these days. So you want to install your IDE, and then you want to open up that project. Again, if there's a project checked in for you or committed when you clone your repository and you already have a project file here and a workspace in the IDE that you're using, then everything is just going to work. You can just open up that directory or project and you should have access to all the information without any issues. But if you're using a different IDE or the professor hasn't checked in this information, then you need to create a project in this same directory and you need to add and make sure that it can see this information here. And sometimes that's a little tricky. You might have to do that several times and try things, delete files, re-add files, move stuff around. Once you finally get the process down, it should be easier for later assignments. But that's usually the trickiest part of all of this.